Imagine a world where aging is a thing of the past, a world where people live indefinitely, free from the slow decay of time. What if the body didn't wear down, cells didn't age, and diseases related to getting older simply didn't exist? Now consider this. If humans could live forever, how would it change our lives, our societies, and our world? Why aren't we immortal yet? Could science ever bring us closer to living forever? The answer lies in something called the Hayflick Limit, a natural barrier stopping us from endless life. But what is the Hayflick Limit? And more importantly, is there any way to overcome it? In this video, we're diving deep into why we age and what keeps us from immortality. We'll explore the cutting-edge science, the ethical questions, and the surprising reasons behind why eternal life might not be as great as it sounds. So, stick with us because what you'll learn may just change the way you think about life and death. Aging has been one of the greatest mysteries in biology for centuries. Ancient civilizations sought the fountain of youth, while modern scientists strive for ways to extend human life. Yet, no matter how advanced our technology has become, we all inevitably grow old and face the inescapable end. This natural decline is tightly linked to a concept called the Hayflick Limit. First discovered in the 1960s by American anatomist Leonard Hayflick, this concept suggests that human cells are only capable of dividing a finite number of times, about 50 to 70 divisions before they stop. When cells hit this limit, they enter a state called senescence, where they no longer divide or regenerate. The consequence? Aging, diseases, and eventually death. But why does this limit exist? And what would happen if we could bypass it? As we unravel the mystery of the Hayflick Limit, we'll explore whether immortality is within reach, or whether it's just a dangerous fantasy. At its core, the Hayflick Limit poses a frustrating barrier to longevity. Our cells, the basic building blocks of our bodies, have an expiration date. Once they reach their division limit, they no longer replicate efficiently. This gradual degradation of cellular function leads to the deterioration of tissues and organs, and it's this process that causes aging. The mechanism behind the Hayflick Limit is tied to something called telomeres. Telomeres are protective caps at the ends of our chromosomes that prevent DNA damage during replication. Each time a cell divides, a tiny portion of these telomeres is lost. When telomeres become too short, the cell can no longer divide and is forced into senescence. So, what if we could prevent telomeres from shortening? Could we stop aging in its tracks and achieve immortality? As simple as it sounds, the implications of such a discovery are far from straightforward. Immortality has long been a dream of humanity, but could it actually turn into a nightmare? To understand the limits of human life and what might happen if we could overcome them, we need to dive deeper into the science of aging and cellular biology. Research has already made great strides in manipulating telomeres. In fact, in some experiments, scientists have been able to extend the life of certain cells by lengthening their telomeres. But there's a catch. Longer telomeres also mean a higher risk of cancer. You see, when cells divide uncontrollably, they become cancerous. So while prolonging telomeres could theoretically delay aging, it would also increase the likelihood of tumors forming. This presents a fundamental trade-off between longevity and the risk of developing life-threatening diseases. It's not just about living longer, it's about living well. Then there's the issue of senescent cells, which accumulate as we age. These zombie cells don't die, but they no longer function properly either. They contribute to inflammation, tissue damage, and age-related illnesses like arthritis, Alzheimer's, and heart disease. So, even if we could extend the lifespan of healthy cells, we'd still have to deal with a buildup of dysfunctional cells in our bodies. In recent years, there has been a surge of interest in anti-aging research, with a focus on targeting these senescent cells. Treatments like senolytics, which are drugs that clear out senescent cells, have shown promise in laboratory studies, rejuvenating tissues, and potentially extending healthy lifespan. But how far are we from applying this research to humans? And even if we could slow down or halt the aging process, should we? Here's the big moment. What would actually happen if we achieved immortality? Imagine for a second that science finds a way to break through the Hayflick Limit, keeping telomeres intact and eliminating senescent cells. People no longer age. Death from old age is no longer a concern. Sounds like paradise, right? Well, not so fast. Beyond the scientific hurdles lies a plethora of moral, ethical, and social dilemmas that come with immortality. Let's start with overpopulation. If humans were to live indefinitely, the Earth would quickly become overcrowded. Resources like food, water, and space would become even more scarce, leading to unprecedented levels of poverty, starvation, and environmental degradation. What would happen to economic structures based on growth and retirement? How would healthcare evolve in a world where death is no longer a natural endpoint? Furthermore, immortality could create a widening gap between the rich and the poor. If life-extending treatments became available, it's likely they would be incredibly expensive and accessible only to the wealthiest individuals. This would create a world where the rich live forever while the poor continue to face the realities of aging and death. The social and economic inequalities would become unimaginable. There's also the psychological toll of eternal life. Living forever sounds great in theory, but what would it actually be like to see everyone around you grow old and die, while you remain unchanged? Would life lose its meaning without the finite nature of time, pushing us to make the most of it? As humans, we often find purpose in knowing that life is short. Would that purpose dissolve in the face of immortality? Aging and death, though often feared, serve important purposes. They allow for the cycle of life to continue, for new generations to rise and innovate. They provide a context for life's experiences and a motivation to live fully. Without death, life might become monotonous, devoid of the urgency that gives it significance. From an ethical standpoint, we must consider the broader consequences of extending life indefinitely. Are we prepared to deal with the social and environmental ramifications? And how do we ensure that advancements in life extension are accessible to all, not just the privileged few? While the idea of immortality might sound appealing, the reality is much more complex. The Hayflick Limit is not just a biological phenomenon. It's a reminder that life's impermanence may be one of its most precious qualities. As we continue to advance in science and medicine, questions about human longevity and the potential for immortality will only become more pressing. We must engage with these issues critically and thoughtfully, balancing the desire for a longer life with a need for fairness, sustainability, and meaning. If this video made you think about life, death, and everything in between, make sure to share it with others. What do you think about immortality? Would you want to live forever? Let us know in the comments below. Let's start a conversation about the future of humanity. And don't forget to hit that subscribe button and turn on notifications so you don't miss our next deep dive into the science and ethics of human life. Remember, sometimes the most important things in life aren't about living forever. They're about making the time we do truly count.